There. In the following video, I will answer for you the AQA Unit 2 Maths GCSE March 2011 past paper. Okay, starting with question 1. It says the nth term of a sequence is given by n squared plus 50. That means that if you want to work out the 10th term, put n as 10 and that will help you work it out. They want the first three terms. So the first term must be 1 squared plus 50. 1 squared is 1 plus 50 must be 51. The second term is 2 squared plus 50. 2 squared is 4. 4 plus 50 is 54. And the third one is 3 squared plus 50. 3 squared is 9. 9 plus 50 is 59. It says how many terms in the sequence are less than 100? Okay, well, why don't we see what value of n makes the sequence equal 100? So if I was to work out what the nth term would have to be to get something like 100 or close to 100. Now let's just think about n. Why don't we choose n to be 7, let's say. 7 squared plus 50, 7 squared is 49 plus 50 would give me 99. And 8 squared, the next term, plus 50 would give me over 100. It would be 64 plus 50, which would be equal to 114, which is too much. Okay, so how many terms are less than 100? Well, the first is, the second, the third is, all the way up to the 7th. So in total, 7 terms are less than 100 because the 7th term is 99. Anything over the 7th term would be bigger than 100. Okay, list of ingredients. The key thing here is the ingredients serve 4 people. Marco is making a meal for 14. How many grams of minced beef does he need? Well, we know that he needs, for 4 people, he needs 450 grams of minced beef. So we want to work out 14. Easiest way to probably do it is say that 2 people would therefore require half that, which is equal to 225 grams. So 14 people would need 7 times 2 people's worth. So you multiply 14 people would be 7 times this number. So you want to do 7 times 225. Well, let's do it in parts. Let's do 7. We could do a separate work in here. 7 times 200 is equal to 1,400. And then the 7 times the 25. Well, 4 times 25 is 100. So 7 times 25 is equal to 175. So you add those two things together and you get 1,575 grams. So the final answer is 1,575 grams. Question 3. Work out the value of the following given that x is negative 6, y is 4, and w is negative 2. All you've got to do is substitute in here using brackets and being very careful when you do so. Let's substitute in. X is negative 6, put that in brackets. Y is 4, put that in brackets. Divided by x is negative 6 plus w is negative 2. Now just work it out. Negative 6 times 4, a negative times a positive is a negative, so that would give you negative 24. Negative 6 plus negative 2. I owe you £6, I owe you another £2, overall I owe you £8, so negative 6 plus negative 2 is negative 8. A negative divided by a negative is a positive, and 24 divided by 8 is equal to 3. So your answer for this is simply 3. Question 4. Bella wants to buy 12 tins of baked beans for a barbecue. the two supermarkets have this following special offer. Which is cheaper? It's a 5-mark question. Do you remember at the end to state which is cheaper? Even if your calculations show which is cheaper, state which is cheaper for a mark. So let's do price save. So price save. Normally, a tin costs 50p, but there's a 30% discount off all tins. So she wants to buy 12 at 50p, and that would be £6. But there is a discount of 30%, so you could do £6 times 0.7. That would work out a 30% discount, and you would get £4.20. You could do this, like if that's not clear to you, you could work out 10% of £6, which is 60p. So 30% must equal £1.80, and then do £6, subtract £1.80 to get £4.20. So it would cost her, to buy her 12 tins would cost her £4.20. Okay, let's do what cost cut costs. Cost cut. They say that normally the tins are 48p, but you pay for 3 and you get 1 free. So if you pick up 4 in your basket, you only have to pay for 3 of them. If you pick up 12 in your basket, you would only have to pay for 9 of them, because every time you pick up 4, you only pay for 3. To get 12 tins, you'd have to pick up a set of 4 tins 3 times, so you'd end up paying for 9 tins. So cost cut is 9 tins multiplied by 48p, or 0.48. Okay, how would I work that out? Well, 9 times, let's just do 9 times 40p. 9 times 4 is 36, so 9 times 40p is £3.60. 9 times 8 is 72, so 9 times 8p is 72p. You add those together and you would get £4.32 for cost cut. Therefore, you've got to state which is cheaper. Price save is cheaper. That would get you the marks you require. Okay, let's move on. Question 5. And it says that the cost, capital C, of hiring a circular saw for D days is shown in the graph below. What is the correct formula for the cost, capital C? Now, a way of thinking about that is, we have here a y-axis and an x-axis, and we know that the equation of a straight line is given by y is mx plus c the intercept, m the gradient, c the intercept. We've got the same here, it's just that in this case the y-axis is the capital C axis and the x-axis is now called the little d axis. So we're looking for an equation of this straight line in the form capital C is md plus little c. If we want to work out what the formula is for cost, if we worked out the equation of this straight line, that would give us the formula. So the aim of the game is to work out what is our m on this straight line and what is our c. Remember, c is where it crosses the y-axis, i.e. here. Each little square is worth 2 because 5 is worth 10. So this point here must be the point 16. So c must be 16. M is the gradient. As you go across one unit here, you go up 1, 2, 3, 4 squares, you end up going up 8. So m must be 8. So what's the equation of this line? It's c is 8d plus 16. It's equal to this one here. So just write that in for our benefit now. The equation of this line here is c equals 8d plus 16. Okay, 5 part B. It says the cost of hiring a circular saw is given by this formula. Sam thinks that the Woods tool hire is always cheaper. Is it true? Well, there's lots of ways to do it. You could you could compare these for various values of D and see if it's true that wood tools is always cheaper. I would suggest drawing this graph, and it's much easier that way. We want to draw the graph C equals 9D plus 11. This means this graph crosses at 11, which is this point here, half a square up from 10. And 9 tells us that as we go across one unit, we need to go up 9 squares. We need to go up 9 values. So if we go across here one, we need to have gone up to 20 in order for that to be the correct line. As we go across one unit, we need to go up 9, so that'd be 1, 2, 3, 4.5 squares, would be something like there. Draw this straight line in. Now clearly you can see, is it always true that the cost of this one here, which we said was branch tool hire, is that always more expensive than Woods tool hire? Or, well, no, it isn't, because actually after this point here, which is somewhere in the region of like 4 days, it actually turns out that the wood tools hire becomes more expensive than branch tool. So I would say as my answer to that, is it true? I would tick no, and I would actually state, look at graph, and I would say it's about 4.5 days. I would say after 4 or 5 days, it turns out that wood tool is actually more expensive. Wood tool more expensive. Okay, and simple as that. Okay, question 6a, expand the following. Simple. W times W is W squared. W times 4 is 4y, as 4w, so you get a subtract 4w. Factorise the following. The highest common factor of 8t and 24 is 8. So 8t divided by the 8 gives you just t, and 24 divided by 8 is just 3. So you get 8t plus 3. Times it out just to check you got it right. Expand and simplify the following. Y times y is y squared. Y times negative 2 is negative 2y. 7 times y is plus 7y. And 7 times negative 2 is minus 14. Tidy it up. Negative 2y plus 7y is plus 5y. So this simplifies to y squared plus 5y minus 14. Okay, question 7, an approximation or estimation question. Remember I said when doing these, round everything to one significant figure, it makes your life a lot easier. So looking at the top number, the first non-zero digit is a 1, it's in the tens column, so round this to the nearest 10. So the thing you're trying to work out is approximately 10 squared on top. Look at the bottom, the first non-zero number is 4, it's in the tenths column. The nearest tenth to 0.496 is 0.5, so round that to one significant figure to 0.5. 10 squared is 100, 100 divided by a half. How many halves in 100? Well, there are 200. So, or you could think of it as dividing by a half is like multiplying by 2. So to work this out, this would be approximately 200. Question 8. Concrete is made by mixing cement, sand and gravel in the ratio the following. So cement to sand to gravel is in the following ratio, 1 to 2 to 4. A builder mixes 455 kilograms of concrete. How much gravel does he need? This is a very straightforward share in a given ratio question. So how many parts do we have in total? We have 1 and 2 add 4. So our parts is 1 plus 2 plus 4, and that's equal to 7 parts. How much is 1 part worth? Well, 1 part must equal 455 455 divided by 7. Okay, let's just do this in a separate bit of work, and why don't we do some long division? We do 455 divided by 7. Does 7 go into 4? No. Does 7 go into 45? Yes, it does. 6 times, because 6 times 7 is 42. That leaves us with remainder 3. Does 7 go into 35? Yes, 5 times. So 1 part must be equal to 65 kilograms. The question wants the gravel part, so for gravel, we know that gravel has 4 parts, so we do 4 times 65. Well, 4 times, you could break that as 4 times 60 and plus 4 times 5. 4 times 60 is 240, 4 times 5 is 20, so 240 plus 20 is 260 kilograms. Okay, question 9a, solve the following. Easiest way to do this is probably multiply out first. 4 times x is 4x, 4 times 3 is 12, and that must equal 17. Now subtract 12 from both sides. You would get 4x is equal to 5, and then divide both sides by 4, and you would get x is equal to 5 divided by 4, and 5 divided by 4 is 1.25. So x is equal to 1.25. A little double check to see if it's right. 1.25 plus 3 is 4.25, or 4 1/4. 4 1/4 times 4 is 17, so I know I got that right. Okay, solve the following inequality. Remember, just think of this as an equal sign, just taking into account that if you multiply or divide by a negative, you swap the sign in the other direction, but in this case we won't have to do that. Think of it like an equals, add 1 to both sides, so you get 2n is bigger than 6, then divide both sides by 2, n is bigger than 3. N bigger than 3 is our answer. Okay, 2 straight lines are shown in the picture. Prove that the lines never meet. Now 2 lines never meet only if they're parallel. So we need to show, okay, lines are parallel or that they have the same gradient. That means that they have the same gradient. Okay? Well, let's work out the gradient of each line. Why don't I call that line 1? I'll call that line 2. And let's just mark in all the coordinates we know. This point here has y coordinate 2, but its x coordinate is 0. So this point here is 0, 2. This point here is 0, negative 3. This point here is x is 0, but x is 9, but y is 0. So that's 9, 0. Okay, we've got all the coordinates we need. Let's just write the coordinates down. We've got the following x, y, like that. So let's just write them in that way. Let's just write these two. Let's do line 1 first. I just want to say the line 1, we've got the following coordinates. We've got 6, 4, and we've got 0, 2. And for line 2, we've got the coordinates 9, 0, and there's coordinates 0, negative 3. Okay, now you'll remember that the gradient of a line, there's a formula for it, is the difference in y's divided by the difference in x's. So in particular for line 1, let's take the y's away from each other. 4 take away 2, divided by 6 take away 0. 4 take away 2 is 2, 6 take away 0 is 6, so you get 2 over 6, or a third. Let's do the same for line 2, the gradient. The y's is 0, take away negative 3, divided by 9 take away 0. 0 minus minus 3 is plus 3, and 9 take away 0 is 9. So 3 over 9 is a third again. So you've shown they've got the same gradients. So you can say same gradients, so lines never meet. So same gradients, which implies lines never meet. Question 11 says that in a sale, a TV is reduced in price by 20% and the sale price is £280. After the sale, the price goes back up to the original price. Matt has £340 to spend. Can he afford the TV when it goes back to its original price? So we have to find what this original price is. Okay, well, in a sale it's reduced by 20%. So you had 100% worth of the price and it's reduced by 20%. So you're left with 80% of the original price. And you know that's equal or equivalent to £280. So in particular, let's say 10% is 280 divided by 8, which is equal to 35. So 100% must be that times 10, which is equal to £350. Do state at the end, can Matt afford the TV? So state original price is £350. So Matt can't afford TV. Do state that for your mark at the end. Okay, question 12, part A. It says write the following number as an ordinary decimal. It's in standard form, it's a small number because you've got a negative power of 10. Quick way to do this, because it's a small number and it's a -3, you know there are going to be 3 zeros at the start of the number, and then you write your number 5 to 8. The decimal point always comes after the first 0, so it looks like that. Another way of doing it, thinking about it more clearly, if you're timesing by 10 to the -1, really what you're doing is dividing by 10, and you're doing that 3 times. You're dividing this number by 10 3 times, or dividing it by 1,000. If you divide that by 1,000, you get this answer. Okay, work out the following. 7 times 10 to the 3, all squared. Well, that means, by definition, 7 times 10 to the 3 times 7 times 10 to the 3. We can do multiplication in any order. So in particular, why don't we do the 7 times the 7, and then we'll do the 10 to the 3 times the 10 to the 3. 7 times 7 is 49. 10 to the 3 times 10 to the 3 is 10 to the 3 plus 3, which is 10 to the 6. However, my answer is not in standard form yet because this number is bigger than 10. I need to make it a number between 1 and 10, so 4.9. And because I've divided that first number by 10, I need to times this number by another 10 to make them the same. So this will be 4.9 times 10 to the 7 is your answer. 4.9 times 10 to the 7. Okay, moving on. Question 13. Make h the subject of the formula. We want h equals something. H is currently inside a bracket and being multiplied. So free it from its bracket, times everything out. 2h minus 2y is equal to 5y plus 3. You want h by itself, so add the 2y to both sides to get the y moved away. So you would have 2h is equal to 7y plus 3. And finally, to get h on its own, divide by 2. So divide everything by 2, and you'll get h is equal to 7y plus 3, all divided by 2. And hence, there is your answer. Question 14. Show clearly the following is 8. 4 to the 3 over 2 can be written as 4 to the 1 over 2, all to the power of 3. 4 to the 1 over 2, or 4 to the half, means the square root of 4, and that has to be to the power of 3. The square root of 4 is 2, and then 2 to the power of 3, and 2 times 2 times 2 is 8. Hence we've shown our answer. It says hence or otherwise work out the value of y in this case here. Now, in order to solve equations with index notation, it's always best to have the base numbers on all sides of the equation the same. So the best base number to choose here would be 4, because there would be a 4 here then, and if we could write 8 as a power of 4, then we would have the 4 as the base on both sides. So keep our 4 to the y as it is on the left hand side. That is equal, well, from part A, you know that 8 is equal to 4 to the 3 over 2. So instead of writing 8 here, why don't we write 4 to the 3 over 2, and all of that to the power 6. So that means 4 to the power of y must be equal to 4 to the 3 over 2 to the power of 6. The power of the power rule says you times the powers, and 3 over 2 times 6 is 9. So that would be 4 to the power of 9. Now we're in a good position. 4 to the y equals 4 to the 9. The only way this can be true if y is 9. So y is equal to 9. Solve the following equation. Well, what we're going to do here, we've got a quadratic equation. In order to solve it, I can try and factorise, I can use the formula, or I can complete the square. For a change, I'm going to use the quadratic formula, because the numbers are quite big here. Because there's a 5, a 14 and a 24, trying to factorise might be quite difficult. So you know what I'm going to do? I'm going to state my A is 5, my B is 14, and my C is negative 24. I'm then going to work out B squared minus 4AC, because it's easier when I'm substituting into my quadratic formula. B squared would be 14 squared, subtract 4 times 5 times negative 24. Well, what is 14 times 14? Well, you have to know your squares up to 15 times 15. That is equal to 196. Then we've got minus 4 times 5 times 24. Well, why don't we just be careful how we do it? Why don't we do the 5 times 24? 5 times 24, well, 5 times 20 is 100, 5 times 4 is 20, so that would give me 5 times minus 24 is minus 120. Then minus 4 times minus 120 is positive 480. So I get positive 480. So working this out, 196 plus 480 would give me 676. Okay, so then work out the square root of b squared minus 4ac, and that's going to be the square root of 676. What number multiplies by itself to give this? Well, you know that 25 times 25 is 625, so this seems like it would be 26, and indeed it is 26. So then work out our x. X is on the one hand, remember our quadratic formula. The quadratic formula is, and we have a song, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So there are two solutions here. On the one hand, x is negative b, negative 14, plus the square root of this, which we've said is 26, all over 2 times a, which is 10. So x would equal, on the one hand, if minus 14 plus 26 would give me 12. 12 divided by 10 is equal to 1.2. So x is 1.2 on the one hand, and on the other hand, we would get x is equal to minus b minus 26 over 10, minus 14 minus 26 over 10, that would give me minus 40 over 10, which is x is minus 4. So the two answers are x equals 1.2 and x is equal to negative 4. Okay, question 16. A bag contains blue and green counters. So let the number of blues be b, let's say, and the number of greens be G. If there were 3 times as many blue and the original greens, there would be 62 balls in the bag. So if there were 3 times the original blue plus the number of greens that you started with, you would have 62. I'm going to call that equation 1. Relates to that. Equation 2. If there were twice as many greens and the original blues, you would have 59. So if you had the original blues and twice the greens, you would have 59. I'm going to call that equation 2. Okay, let's try and solve these. We've got ourselves 2 simultaneous equations, and we're going to try and find how many blues and how many greens without guessing. It says without using trial and improvement. So, what we could do, why don't we multiply this whole equation by 2? And that would get us 2g here. And then when we have the coefficients of the g's the same, we could subtract equations eliminating g, for example. So if I times that by 2, I would get 6b plus 2g is equal to 124. I'm going to call that equation 3. Underneath it, I'm going to write my equation 2 again. I'm going to say b plus 2g is equal to 59. That was equation 2. Now I'm going to take equation 3 and I'm going to subtract equation 2. 6b take away b is 5b, 2g take away 2g is no g, and 124 take away 59 is equal to 65. So dividing both sides by 5, b must be 65 divided by 5, which is 13. Okay, to find how many greens then, substitute your b equals 13 into, let's say, equation 2. So you would get 13 plus 2g, substituting into this equation here, equals 59. And now just solve that equation. Subtract 13 off both sides, you would get 2g is equal to 46. Dividing both sides by 2, I would get g is equal to 23. Hence my answer, green are 23 and blue are 13. Okay, we're nearly there now. Work out the value of x if the following equation is true. Give your answer in the form a root b, where a and b are integers or whole numbers. Okay, the first thing I'm going to do to this equation is I'm going to multiply both sides by 5 minus root 3. The reason I'm going to do that is if I multiply the left-hand side by that, I'll just get the numerator, x root 2, and over here I will have removed a fraction therefore from the left-hand side, and the right-hand side will be something I can actually work out. So multiplying everything through by that, I will be left with, on the left-hand side, x root 2, and on the right-hand side I would have 5 plus root 3 multiplied by 5, subtract root 3. Okay, so x root 2, let's multiply this out. Before I launch into multiplying first times first, first times second, I can notice that this is the difference of two squares, a plus b multiplied by a minus b, and to work that out quickly, you could do the first number squared, which is 25, subtract the second number squared, root 3 squared is 3, so you would get the following. So x root 2 must equal 22. Therefore x, dividing both sides by root 2, must equal 22 divided by root 2. However, the question does not want it in the form a root b, it's not in that form yet, and mathematicians hate surds on the bottom of fractions, it makes them unhappy. So multiply this whole fraction by root 2 on top and bottom, so you would get 22 root 2 over root 2 times root 2 is 2, and you can simplify that. 22 divided by 2 is 11, and you're still left with your root 2. So a is 11 and b is 2. X is equal to 11 root 2. or 11 times the square root of 2. Okay, question 18, the very last question here. It says the sum of the squares of two consecutive integers is 1 greater than twice the product of the integers. It gives you an example to help you. Say if you pick two consecutive integers, 9 and 10, if you square them and add, you get 181. Whereas if you times them and then double, you get 180. So squaring and adding always seems to be one bigger than timesing them and doubling them. It says prove this result algebraically. Okay, to do that, let your two consecutive numbers, let your consecutives, let's say be n and n plus 1. Okay, let's square them and add and see what we get. Let's do n squared plus n plus 1 squared. N all squared just gives me n squared. And n plus 1 squared, well, I'm just going to write it like this, just to make sure we don't make any mistakes when we're squaring that. N times n is n squared. So over here I'm going to get, if I times this out, I'll do it in a different pen to show I'm timesing this out. N times n is n squared, n times 1 is n, 1 times n is n, and 1 times 1 is 1. So tidying that all up, n squared plus n squared is 2n squared, and we've got a plus n is plus 2n, and we've got a plus 1, so it just gives us the following. Okay, that's what you get when you square the integers and you add. Let's times the integers and then double them. So let's multiply the integers n and n plus 1 and then double it, see what we get. Well, let's keep the 2 out of action first. Do n times n and n times 1, so you get n squared plus n. Now multiply it out, you get 2n squared plus 2n. Now it's very clear to see that this is always 1 bigger than this, because if you look at what's happened when we've multiplied them out, you could write that 2n squared plus 2n plus 1 is 1 bigger, clearly, than 2n squared plus 2n. And hence you have shown your result. Thank you for listening, and I hope you found the following useful in your revision for Unit 2. Thank you for listening.